Okay, guys. Today is our first public dev recap. You are all welcome. The goal of this call is where all tech units show their retrospective of their work done during the last month. And so is a moment where all tech units share their work, their achievements, and we also celebrate together our achievements. Okay? So I will not wait more for us to have time to answer questions at the end. So I would like to call maybe Vitor Fusco to start bringing the updates from the machine emulator team. Is it possible, Vitor?
Hello. Yeah, sure.
Great. Come on.
Hello, everyone. My name is Victor. I'm going to present the updates since the last meeting for the machine reference unit. Just a minute. I'm going to share my screen. Can you guys see it?
Not yet, Vitor? Yes, now it is.
All right. So this is the dev recap for the updates since the last meeting. This is the first public one. The agenda is going through the releases, the progress on the microarchitecture, the hypervisor, the hashing device. There is also a WebAssembly prototype, and the rest of SDK. We have some changes as well, the kernel tools and toolchain. And since we just released, all the changes mentioned here are not yet merged. They are on PRs being reviewed. Okay, so the last release that we did was the machine emulator SDK, the 16.2. All these components were upgraded. The server manager on the end does not make part of the SDK, but for the rollup to interact with the machine emulator, we also release this regularly. For the microarchitecture progress, I will ask Pernambuco to talk a little bit. Perna, are you there?
Yes, can you hear me?
Yes.
Yes, Perna.
Okay, so micro. So when the microcode executes completely, it advances the cycle of the big machine by one and halts. At that point, if we want to, at that point, in order to make the hash of the entire machine to be the same as the hash of the same machine advanced without the microarchitecture, we need to reset the state of the microarchitecture. And that entails restoring all registers and copying back the original image of the microarchitecture RAM. And this needs to be verifiable. In order to be verifiable, we want to return a log from the reset UART state method. And this log should include all of these operations, the resetting of the registers, restoring of the RAM image, and so forth and so on. It turns out that this could be prohibitively large, this log, because of the one write access where we copy the entire image of the microarchitecture RAM. But it turns out that we can optimize the log size by, instead of providing all data for the accesses, we would simply provide the pristine hash of the state of the entire microarchitecture state, right? So in order to do that, we need to do some changes in the layout of the log accesses in order to allow it to require hashes, but having the data optional. So the hashes would be mandatory and the data optional in order to allow us to, for this big write, we would be specifying simply the pristine hash of the microarchitecture state. So there is some, we're doing work for changing the layout of the log in order to support this optimization. And also we want to, since we are adding, now we have two verifiable methods. One is step, we do one micro step and we can verify as it's currently implemented. Now we want to reset the microarchitecture, return a log, and also verify the same operation. So we are adding changes to the API to provide a method for verifying this operation, same way we verify a step. So that's the gist of it, pretty much it. So Victor, back to you. Thank you.
Thank you, Pernambuco. And also, so the hypervisor has been the first proof of concept of the hypervisor feature is being implemented for some time now. We have been polishing it and reviewing it, and Alex will going to say a little bit what he has been working on the past month.
Yeah.
Please, Alex.
I sound okay.
Hey, Alex.
Cool. Hey. So as Victor mentioned, we are doing some final touches on the hypervisor. We are testing it and refining. So we reviewed the logic of the registers that hypervisor adds to the machine, and a bit reordered this logic. So and it recovered the bug that we successfully fixed. This is what the second bullet point is about. Then we also trying to benchmark the hypervisor to in different conditions to evaluate the set of the tasks which are useful, usable, which are suitable. Sorry, which are suitable for hypervisor. So the latest data we gathered is basically 3 times slowdown in comparison to the running the same benchmark on the emulator. This is a CPU bound benchmark. So and during the benchmarking, we also hit into a bug when just another one when the hypervisor
Come on to stage, Diego.
Hello, can everybody hear me?
Yes.
Okay, so I had to get into the stage. How threatening. Anyways, so as Victor said, the hashing device is a way for us to obtain blocks of data that correspond to a given hash, given that all the possible blocks of data are part of a blockchain. And we are in conversation with a partner that might help us implement the surrounding pieces of software that will make this really useful. And so as far as the machine emulator team is concerned, we will work together with them to bring the device back to the machine, bring the driver support back to the machine, and help them hook this up to the database of hashed blocks, and also help them prototype an interesting way of accessing it from within the machine. So yeah, so I wrote a small document explaining what the device is, the several issues involved in it, and we can make this available for whoever wants. Just get in touch with us, and we'll send you the document. Yep. That's
All
it.
right. Thank you, Diego. So we have this cool prototype that Eduardo is working on. It's the Cartesi machine on the browser. It's based on the WebAssembly technology. So maybe some of you have already played with it, but now we can run the machine on the browser. We can have some, just a minute. Lost my screen here, just a minute. Yeah, here.
Part of
It's running. This is the kernel log. And yeah, we can play, and there are some cool ideas circulating. Maybe we'll put this to some use. I'll ask Eduardo to talk a little bit more. Eduardo, please.
Eduardo, I cannot hear you yet. Maybe he has some sound problem. He is online, but no sound. I think we can move, and then Eduardo tries to talk, Victor.
All right.
Oh, now he's muted. Yeah, Eduardo,
Okay,
could you try to leave it and read?
Okay, I'll come back to this later. I'll ask Marcelo to talk a little bit about the updates on the other components. Marcelo, are you there?
Yes. Hello, can you hear me?
Yes.
Okay. Such a boring stuff now. So compared to the WebAssembly stuff. So
yeah, sorry. It's not boring. The things that make it happen, right?
No problem. I'll go quickly about this. So we have a fork of the JNX2FS tool. This is responsible for creating the file system that's going to run. And since we have a couple of patches, we decided to add it to the toolchain image to make it easier for other teams to use this. So other than that, we've been prototyping some API changes to the Rollups device, including mapping the read region. So it's a memory where there's going to be the read from the rollups. And so instead of copying memory into the kernel and to the app, we can map this region, and the app can access it directly. So we don't have to copy memory unnecessarily. Other than that, there's some changes to maybe do the KCAC in user space and do the EVM encoding for vouchers and notices also need user space. So this would simplify the kernel driver a bit, and something we're investigating. Other than that, there's the OpenSPI port, including the reset and the arguments via HTTP. So OpenSPI is the BIOS equivalent. So for PCs, we have BIOS. For the RISC-V, we have OpenSPI, and it's responsible for booting up the machine and the very lowest level of software running. And we need this to for the hypervisor. And other than that, there's the exit status forwarding that would enable for when the app exits for some reason, we can see exit status on the emulator. Yeah, I guess that's it. Back to you, Vitor.
Can you hear me now? Thank you. Yeah, we can. Thank you, Marcelo.
Yes, Eduardo. I can.
Okay. So we got the Cartesi machine to run in the browser by compiling it to WebAssembly. This will allow the use of the Cartesi machine not only in the Rollups backend, but also for some front-end use cases. To do this, we had to refactor many of our dependencies. In this slide, we have all the dependencies that needed changes to accomplish this. We had to change the library that performs hash calculation. This gave us the opportunity to experiment with the XKCP library, which supports AVX2 instructions, and it effectively doubles the machine root hash calculation performance on processors that support AVX2. Not only the Cartesi machine can be compiled to WebAssembly now, but also it's much easier to compile it from sources because it's more dependency-free and self-contained. The emulator also got instructions on how to compile to WebAssembly in the README. So this is the changes I made for WebAssembly.
All right. Thank you, Eduardo.
Thanks.
Yeah, Claudio. So this was the update for the past month. So back to you.
But Victor, we already have a question for your team related to hypervisors, so please take a look. At the end, we can give your mic again, okay? And so the next tech unit, let's go. Danilo, do you want to go next?
Yeah, can you hear me?
Yes, very well. Welcome.
Cool. Let me put my screen on. Yeah. Hello everyone, my name is Danilo. I'll give some updates from different teams. We can start with the Onchain Unit, which basically handle all the smart contracts that we have on the Rollups platform. So I will give the stage to Pedro. Or DApp, Pedro.
Yes, hello guys, can you hear me?
Yeah.
Okay, hello everyone. Let's talk about the Onchain team. This past month, we'll be focused on some new features. First, the quorum authority that allows a DApp to be validated by multiple validators in a democracy. So they submit claims, and a claim that is submitted by a majority is valid. That's a step up from the single authority. And we also started doing the first complex vouchers, and they extend the behavior of the vouchers we already have. For example, now we'll be able to have vouchers that can only be executed after a certain time, or vouchers that have expiration dates and things like that. We also start experimentation with ENS Relay. That's super interesting. I'm really excited about this new feature that we started to think about how to do it, and we have a small prototype already. And it will allow a DApp to interact with an ENS domain name instead of an external account. So one of the implications of that is that you can have a DApp that is a game, and a user can interact with this DApp through his ENS account, his ENS name, and then he can sell his ENS name with all the history of the game, and he doesn't have to lose his original account, his private key. For the DApp, only the name exists, and our history in regards to that game is transferred with the ENS cell. And this part is less relevant for the general public, but it's important for collaborators and for people that look at code. Now we are splitting the main repository, and now we have a repository specifically for the on-chain team and for contracts. There's the Rollups contracts repository, the links here. And this change came with some updates to workflows that guarantee better organization. And Guilherme made a really nice effort to create a lot of tags for issues to help you with track your technical depths and or new features, and also to do things like enforce change log management, so we keep it always up to date. Yeah, that's it, guys. Thank you.
Thank you, Pedro. Coutinho?
Yeah, hello. Can you hear me?
Yeah.
Yes, okay. So on arbitration, to contextualize, arbitration is our fraud proof system, which will allow a single honest validator to always enforce the correct result, no matter what. So on that end, we've released the machine solidity step based on the latest version of the SDK. So we are also on a huge refactoring work because we finally reached a very nice milestone, which was resolving our dispute from top to bottom with a real machine and actually executing the step on chain with all the correct proof. So this is like a huge milestone. And from this point, we can actually start building the real client nodes and everything, move from this prototype to the production ready stuff. So yeah, I think that's the biggest news we have. And then there's these minor features that we're working on, which will help us get this production ready. Yeah, thank you.
Thank you, Gabriel. So maybe instead of going to the Explorer unit, we could go to Linneo's unit, which handles the Cartesi node, so we can follow a better order here. You want to take the stage, Linneo?
Yeah, please, let me share. Hello everyone, I'm Gabriel. I'm the lead of the Node unit. So in this presentation, even though we have been working on Rollups 1.0 for a few months, I'm gonna take the opportunity and recap the main features that we did for this latest release. So the first one is Prometheus metrics. Now the node provides an HTTP API that exports Prometheus metrics. So for instance, the dispatcher service of the node has some metrics that help the node runner, the validator, to monitor the node. With that, we can, for instance, create dashboards in Grafana. So this is just an example, but now it's possible to do something like that. and track the number of inputs that the node is processing. And another metric that's useful is monitor how many times since the last claim was made. So for instance, if the node is set up to make claims every hour, you can track if the node is making those claims, and if it's not, you can set up an alert and check what's going on, if everything's all right with the node. The second feature that we added for 1.0 is better support for Redis cluster and TLS. This improves the reliability of the node because now it's able to connect to a better setup Redis, and also allows the node to connect to hosted Redis solutions, for instance, AWS MemoryDB. The next feature is also related to AWS, is now the node is able to use AWS KMS, the Key Management Services, and this allows the node validator to store the blockchain wallet in KMS instead of passing the wallet mnemonic to the node. It's still possible to use the wallet mnemonic. This is useful for local development, but for deploying the node in the cloud, it's much more secure to use a hosted solution like that one. We also renamed a few fields. This is a small change, but for everyone that uses the GraphQL API of the node, it's important to know that there was a few changes, and you should update and take a look in the changelog to see more details about that. Just a few changes, but those who use it should take a look. We also fixed the proofs in host mode. So it is possible to, when running the node in host mode, when you are developing your DApp, you can now properly send notices and vouchers and then validate them after the epoch finishes, even though you are not using the Cartesi machine. This is useful for every developer that needs to verify their application in their local environment, and now they can test it end to end. So those were the features that we delivered in Rollups 1.0. As you could see, they were mostly reliability, security, and observability features. And we did that so the node could be better deployed now that it's ready for mainnet. And now I'm gonna talk really briefly about the upcoming features for Rollups Node 1.1. We are going to support reader-only and validator-only modes, so it will be possible to run a node and only read the inputs, process them, and provide the GraphQL and inspect APIs without trying to send any claims to the blockchain. And it will also be possible to run the node as a validator only, so it won't provide any external APIs, but it will still validate the inputs and make claims to the blockchain. We will also add a post method to the HTTP API to support binary payloads. We will add input status to the GraphQL API. Now it's not possible to know whether the input is pending, accepted, rejected, and or if it has an error. So we will add that. And we also check the Cartesi machine hash during the startup. If the node validator or the DApp developer, when running a local node, use the wrong Cartesi machine, the node doesn't say anything and it tries to process inputs with the wrong machine. Now the node will check it just to make sure there is no error. And we also improved running the node in a single container to make the local experience better. Now it requires several images and Docker containers. We want to deploy. We will stick to Docker for the time being, but we want to make sure it's a little bit easier for those who are using the node. And we also improved the log in the node log in this 1.1 release. And for the node, that's it.
Thanks, Gabriel. So let me share my screen again. Sorry for the back and forth. So Explorer unit, we have a staking Explorer that is online at explorer.cartesi.io. We are also working on an Explorer for the rollups system. We have a prototype already in the code base. We upgraded that prototype to rollups 1.0. We dropped support. We dropped the GURL support. We are now focused on Sepolia only for the testnet. We also migrated from using subgraph as the indexing solution to use subscript instead. And we are now working on a second prototype with a shift in our design. We are focusing now on an input-centric design, and you guys will hear more from this in the next meeting next month. Now updates from the Sunodo unit. For those who don't know, Sunodo is a product and a tool that we are creating to make it easier to develop applications and also to deploy validators on a cloud environment. The first thing that the unit worked on is finalizing the Helm chart for Rollups 1.0. Helm chart is a classic tool to deploy applications to a Kubernetes cluster. And we updated our chart for the latest release. We are working on getting the environment ready for validating the first mainnet application that we're going to deploy, the honeypot. Before going to the honeypot, we deployed one of our examples, a basic example called EchoPython. We deployed that to Sepolia network. We also deployed the honeypot to the Sepolia network as well last week. We are now in testing phase. And work in progress that we are now designing a new application called Operator. The responsibility of the operator will be spawning new rollups nodes dynamically for applications deployed. And this will probably be ready for the next meeting. This is a basic feature that we need to create a service like a rollups as a service on top of Cartesi. Going to Sunodo itself, Sunodo the tool, there's documentation online if you guys want to check it out, docs.sunodo.io. We released the new version of Sunodo 0.7. The main feature was Rollups 1.0, the compatibility with Rollups 1.0 and the latest emulator SDK. We also created a couple new templates for applications, one for Rust, another one for TypeScript, even though we already had a JavaScript one. The TypeScript is just make it easier for TypeScript developers to bootstrap an application. And we are currently working on a deployment system for dApps on testnet or mainnet. This deployment system, we already have some design. We are still discussing some designs and implementation. There is documentation online about this deployment system. The goal is to have a decentralized deployment using a PFS network to distribute the machines and using economics of blockchain to reward the validators. We are also working on 2 new options for the Sunodo run. The Sunodo run is the command that you use to start a node locally for development. We are developing these 2 new options, no backend, which we use it to call host mode. We are changing the name to no backend, and a testnet option, so you can run a node on testnet. And finally, we're also developing a TypeScript framework for developing applications. We're calling DRO. This is kind of a side project, and it's useful for us to eat our own dog food and experiment. So I can give you, I'll take the risk here and do a demo. Gonna be pretty quick. It's live coding, so forgive me if anything goes wrong. You know how this works. So I'm on a shell here. I will create a new application called dev recap, and I'll use the TypeScript template. Oh, sorry, I have the Sunodo CLI installed, latest version Sunodo 0.7.1. These are the commands. So I just create an application in the dev recap directory, right? So I can, so basically just a few files, a Docker file, index TypeScript file. Let me just install the dependencies. Let me launch the code. So this is the main loop of the application. It basically gets inputs and process inputs. So what I'm going to do here is do a quick demonstration of the framework that I'm creating. I'll delete everything that I have here. I will install 2 dependencies, app and VM. Okay, go back to the code. I will create an application, create app, URL. This is the URL of the Rollups server. And I'll just start the server. And if anything goes wrong, I'll just exit. Okay. So what is the server doing? It's basically rejecting any input that is sent to the application. I'll just process one input. Just a second, guys. Sorry. So I'll just process one input. I'll add an advanced handler, data, and I'll return sorry. Now return accept. I will get the data. I'll just do hex to string from data payload. And I'll just hello name. Okay. So just go back to my shell, I'll do sunodo build. It's building the Cartesi machine of the application. Now it's booting the machine and save the machine. So now I'll run the node. Okay. Now I'll just send an input to the application. I'll send a generic input to the local node. Sorry, I'm in the wrong directory. Sunodo send generic boundary mnemonic. I'll send a string encoding, and this is my input. Input sent. And you can see up here, hello Danilo printed from inside the machine. So it works. This was the demo. Back to you, Claudio.
Nice, Danilo. Oh, now we have Carlo from Prototype Unit. Danilo is the goat. Yeah. Sunodo is a really impressive work. Carlos there. So now we have the Prototype Unit recap.
Hey guys, can anyone hear me?
Yes.
Okay. Let's go for just a quick recap. So you can check the whole deal if you want on the core unit updates. We got a lot of prototypes we did. I'm just pasting the link in here. But just a couple of the main things that were done in August or are being done. So beginning, we have this really cool application that was developed by the old product team called the auction. And this auction is a complex application using a lot of Cartesi features. You can create auctions, placing bids, finish auctions, put resources in there like NFTs and stress the portal, all these things. And we had Artur doing front end for it. So let me open the video here. Just a sec. Changing the screen. Okay. So this front end is a nice way to actually test this application. And moreover, if you have a new application you want to start using the same resources, it can also be used as a kind of template. So in here, Artur is just setting a new auction and determining all the stuff. You cannot see the MetaMask transactions though, because he's only recording the screen. So now his pointer in there is just accepting the transaction. And boom, they just set a new auction for ERC 721. Takes a while for the transaction, but yeah. Deposits in the asset. And there it is, the first auction in there. Cool. Another really interesting application that's being developed is So what's this Word Arcade? Back in Paris, we had a really nice application that showcased Cartesi machine power, which was Doom. And this was an amazing job done by Bartel from the emulator team. He managed to do this Doom port to the Cartesi machine that would play in real time. And we developed a nice application in there so that people could actually put their hands on a computer and play Doom on Cartesi machine themselves. And we're taking this a step further. So what's this Word Arcade? The Word Arcade idea is that you have this arcade, just like the old 80s and 90s arcade, in which you go there, you play a game, and you have this high score wall with verified scores of the players. So this Word Arcade, besides being a really nice application, is also stressing a high-level framework that's being developed in Go. Okay, and just another demo here. Let me open the video just a second. So in here, what's happening is that we're first setting up a game that you can play on this Word Arcade. This is a really simple game. That's just an example. It's a counting game. So it's basically a human time stop. So it says like, wait for 5 seconds and press the key. And the closer you are to pressing the key in 5 seconds settles your score. So that's just a really simple application. This Word Arcade allows you to upload any game you want. You just have to comply with the defined API. And we're creating a couple of games, especially, once again, Eduardo from the emulator team is creating a couple of nice games to play in here. And once you upload the game, it's available in there. You can download it, play, and then you can submit your log. So once you play this game, produces a log with your score and another one with your gameplay. And once you submit the gameplay, the Word Arcade replays that same match and displays the score that you actually got for that in a verifiable fashion. So anyone can play and the scores can be checked. This one is an example that was long being asked by the community. So we do have ERC20 portal example on rollups examples that whatever you give it to it, it gives you back. And we have this common request of people wanting to do the same with Ether, but we didn't have an example. So we also put this I don't want your money Ether example. And last thing I wanna display is this image classifier example. So we had Felipe on our team pick up this ImageNet database of images, create a classifier based on it, and then execute it inside a Cartesi application using TensorFlow Lite. For the ones that don't know, TensorFlow Lite is a light version of the TensorFlow framework, which is really popular, might be the most used AI machine learning framework in the world, developed mainly by Google. So this is something huge. It's a really expressive framework and also a really complex one. And this example here is making use of it to classify images that you upload to it. Okay. This was just a quick overview of what we've done in August and things we're working on. And you can check the full deal on the link I provided on the chat. Thanks, guys.
Thank you, Carlo. Nice presentation also. Now we will have our units have talked, speech, machine unit, Carlo, etc. Okay, so now is our Q&A session. We have some questions here that people, our community developers, are adding in our chat. Oh, Karsten, sorry. Go ahead, Karsten. I'm really sorry.
So no worries. Can you hear me?
Yes, very well.
Okay, I'll just share my screen. I can't seem to, so I might need a permission to do that. You can see my screen just fine?
Yeah.
Okay, good. So a little bit of recap from the unit that people seem to forget about, compute. We presented about our work in Linux, running Linux in zero knowledge here in Sakir Warsaw about a week ago. And if you want to come see the slides, you can see the link there. Kind of like our main work streams of the computer team have been that we've been kind of like following up on the work that has been done on the NXM arbitration protocol and having it work in Rust. And what we have tried to do there is kind of like making this component very reusable, not just for kind of compute purposes, but also making it reusable for all the other Cartesi ecosystem products. So our main task is kind of like keeping it up to date and kind of like following the whirlwind of activity that's been happening in it. We've also been focusing a lot around kind of like how do you make really replaceable images containing, for example, Ubuntu with apt-get and running deterministic Rust builds inside it, because we need that for example, zero knowledge circuits, and we also want to build compute and related kind of components within the Cartesi machine itself. We have also done bindings for Rust for kind of communicating with the Cartesi machine, because there's a new let's say new communication protocol in town called JSON RPC that you're talking to the Cartesi machine about. We also spent a fair amount of time kind of like participating in various discussions about where Cartesi could be going. And as kind of like as of last week, we've been discussing a lot also on the expressor sequencer, kind of like playing around with what that technology can do, and kind of paving the way for us to use it kind of like in the ecosystem, talking to legal, etc. And kind of like as I mentioned to the other teams that we're talking about dehashing, that in order to really take advantage of this technology, we for sure need something like dehashing or even DKCG, which is kind of like different kind of commitment technology device for kind of like using this. And yeah, that's pretty much the recap from our side.
Nice, Carsten. Thank you very much. Sorry again. So now it is. Now we have our Q&A session. We have, let me check, last comments. ZK stuff is awesome. Really, Milton. Really. New possibilities coming. So for our first question from the community, we have a question from Lincoln. I would like to ask Vitor or Diego to say something about the following question. Could you explain more about the hypervisor and its role in Cartesi's architecture?
Yeah, I can take that. So the idea of a hypervisor is to allow people to run simultaneously inside a Cartesi machine code that the DApp doesn't necessarily trust, or perhaps code that is even more important than code from the DApp that we can't allow the DApp to control. So for those that don't know, everybody here is familiar with Docker containers, and containers is a way of separating what one program can do to a machine from the rest of what's going on in a machine, right? And this is usually based on C groups or namespaces, and it's basically the operating system is trying to segregate some program and allow it to only see and interact with a part of the machine. And then this is at one level. At the other extreme, there is emulation, right? So emulation is you're simulating an entire new machine from scratch. And hypervisor is this weird thing in which there is some hardware support, right, that allows for more separation. So you don't really need to go all the way to emulation to create perfect separation, but you have this hardware support that makes it more efficient. And then there's two types of hypervisor. There's this level 1 hypervisor and level 2 hypervisor. And in level 1 hypervisor, you have this underlying thing that is not even the OS, is a special hypervisor software that maybe can manage multiple independent operating systems. And then there's this level 2 hypervisor, which is the one that we are testing, that basically the OS runs as kind of a more protected version of what a container would be, right? So the two applications in mind, for example, let's say you're creating a DApp that you want to run user code in your DApp, but you're really worried that the user code could somehow escalate privilege in the kernel and take control of some asset. So you could either do it C groups and namespaces, do it like a container does, but if you're more paranoid, you could launch in a hypervisor. So it's more separate. Or let's say we have some application, some need for, say, a unified wallet that needs to have higher privilege access to the system than even the dApps have. So we could run the dApp inside a hypervisor and have this official hypervisor that we distribute that then runs the dApp, and have the dApp and the code that is run and signed by Cartesi be separate, so that you can be sure that the wallet is being run in a safer way. So those are more or less the ideas. I hope that makes sense.
Great, Diego. There is another one that I think we can link with the emulator team, Unit, just to become in the same domain. It's also from Lincoln. What AI libraries can I run on Cartesi machine? I think this is a very interesting question for us to explain the goal of the Cartesi machine, and also to talk about depths on their self. Diego.
Right. So machine learning, there's this training part, right? And then there's the using part of it. And the training, as you know, is very, very, very computationally expensive. And so I don't see the training of reasonably expensive AI models as something that is viable for the Cartesian machine at the moment. As for taking a model that is already being trained and you're just running, say, a classifier, that will depend a lot on how expensive the thing is, right? So there's, I guess in this question, I can read it in two ways, right? So one is, which libraries can you run? And those would be the libraries that compile and run inside a Cartesian machine, and that will depend. So, for example, we don't have access to GPUs. We don't have access to certain vector extensions. So, if you have source code that gets compiled in C or C++ or Rust or whatever it is, and doesn't use any specialized hardware, doesn't need any specialized hardware, you should be able to run these in a Cartesian machine. Now, will it be performant or not? That is a very wide question, right? It will depend a lot on the application. So if in order to make this thing performant, you need access to you're usually using a GPU, or you're using vector instructions, or you're using a lot of floating point operations, that it might not be performant, right? So the question of which ones can you run, which ones should you run, very different questions, and I guess it depends on the application. As to which ones people have tried, I think that Carlos' group has tried a few and would be better informed than I am.
Great. Do you want to add something to this point, Carlos?
As Diego said, we are testing a couple of things. So TensorFlow Lite is an experiment that Felipe has made. He also put a sentiment analysis in there, and he loaded the model inside the Cartesian machine, just like Diego described. And yeah, so in general, most of the experiments are based on running a trained model inside Cartesi machine, and it provides enough performance to these applications. Yeah.
Is the sentiment analysis available for people to give a try?
Yeah, it's on our GitHub. Just follow the instructions and give it a go.
Yeah, if you could paste it in the chat, it would be nice for people to take a look. Sure. Thank you, Carlo. Another question. I maybe have missed it, but is Cartesi Tech mainnet ready now with Rollups 1.0 or was something missing? Cartesi Rollups 1.0 is on release candidate on our GitHub, and it's in testing phase. So stay tuned, news are coming. Next question. Oh, those are good for Carlo, prototype units. Wow, that decentralized arcade can reignite the development of old school custom ROMs. And another one, Carlo, can we play it, the arcade, now or it is still in development? Can you take this?
Yeah, sure. So about the arcade, I already answered on the chat. So the code is available on our GitHub. If you're a developer, and you can just follow the instructions, pick up the application, run it, upload the stopwatch game, play it yourself. But for the general audience, I would say hold on a bit. We're still polishing the experience, and we're bringing actual nice games, right? The stopwatch is just a demo to check things out, but the really cool ones are being worked on mainly by Bartel, and will be available in the coming weeks. So hold on a bit. And the other question, sorry?
The other one is, can we play it now or is still in development?
Yeah, for developers, it's in there. So you can go there, clone the repo, follow the instructions, and give it a go.
Great. Another one from Ireland. Could you tell us something about Cartesi Rollups that hasn't been added to the Rollups roadmap yet? Oh, Sunodo, for example, is a development, a very important development for the Rollups that is not in the current roadmap. And what I can say is that other new things are coming, and everyone will know it soon. Next, would it be possible in the future for Cartesi to run a complex game like World of Warcraft or Dota 2? I think these ones are good for Diego and also Carlo.
So we get this question a lot, and there's an issue here that is reproducibility, right? These AAA games were designed to work in a way that is basically impossible to make reproducible, right? Especially when you put multiplayer into the mix. So, for example, they were designed to use a GPU, right? And a GPU is almost by definition something that is not reproducible, right? And so I don't see it as something possible to run any of these games inside of a Cartesi machine. And by that I say taking the game as is and running it wouldn't work because it wouldn't be able to access all the resources that it wants to access. So a GPU, sound card, and a bunch of different things, right? Would it be possible to make a game that looks like that run outside of a Cartesi machine to give the experience that you expect from a game like that, and then collect some log and then run it in a reproducible way? It will depend a lot on the game as well, right? So these games usually involve a lot of physics. Not these, but Dota 2 I think involves a lot of physics. World of Warcraft much less. But and physics is expensive, so I don't see this happening anytime soon. Does that make sense?
It does. Dota 2, I don't think it's so heavy on physics, just on the interface, but not on the simulation logic. The main problem though is real time, right? So
yeah,
as Diego said, you don't have a way of making it deterministic. If it's a real time game, you have to have consensus on the order of the inputs, all this stuff, which is it's quite difficult. You could have a really low.
Yeah, I was gonna say, especially when you have multiplayers, right? If it's a single player thing, there's conceptually it's not impossible, right? But if there's multiple players, then you get into the business of like who sent which input when. You need to time them, and if you need to time them, you need to be able to dispute those things. It becomes very complicated very quickly. Go ahead, Carlo.
But as Diego said, you can have like some really good looking games, and if they're turn based, it's feasible. Something like Civilization, for instance, it's feasible. It fits blockchain, so you have the turns. You can make sure that you have the correct order of the moves for all the players, everything that everyone has done, and you can just render some beautiful graphics off chain of the Cartesi machine directly on the client, because that doesn't concern anything on the game logic itself. So yeah.
Let me just go ahead and say something about games in general. We hear a lot about games in blockchain, and the difficulty in putting anything to run on a blockchain is to make it disputable, right? If you have a game in which all players are honest, then you can do pretty much anything that you want, right? But the problem is that if the players are honest, then why do they need the blockchain, right? They just run their games in their own computers. They're honest, so you don't have this problem. So the problem begins when you assume that one of the players, or multiple of the players, or most of the players even, are dishonest and are colluding with each other to screw one of the honest players. And so you hear a lot about this. Oh, we have this state channel that users communicate directly with each other. But then all of a sudden, what if one user decides to stop communicating? How do you know if they really stopped communicating or not, or if it's the other player who's lying that didn't receive the commands? And now you have to be able to dispute that, and the whole thing ends up having to go through the blockchain directly, right? And then is it still playable in this case? Oh no, in this case it's not playable. So you don't have a solution for the gaming problem, right? So you have to when you hear news about, oh, there's some game that works on the blockchain, it's usually going to be some turn-based game, or it's based on a bit of magic, hand-wavy technology that lets you identify. So it's going to be centralized or based on magic or so on and so forth. So you really have to take those with a grain of salt.
Great. Augusto, do you want to bring anything else?
Yeah, just
Good to see you.
Thanks. Great seeing everyone. So just one extra comment on this. I think it's important to keep the distinction between what is possible in terms of gaming because of the layer 2 technology, in this case Cartesi, and what's possible or not because of layer 1. So for example, several of the issues that we raised as complicated in previous discussions and that Carlo and Diego raised again now, they are issues with layer 1. So can you order and make data available for transactions in real time, for data in real time? So for example, Ethereum cannot do this. They have a complicated consensus mechanism, and it takes time for the inputs of the players to arrive and get ordered and mined and so on. So if it could, then Cartesi would take that quite fast, and of course not to the point of World of Warcraft, but I think you could get very interesting games with Cartesi tech if the inputs were ordered by the blockchain in real time by layer 1. So since layer 1 cannot keep up with the speed, there are alternatives. For example, if you have a different data availability protocol, which we currently do not offer, but it's something that can be put in the roadmap if there is interest. I think it would be something that can allow for much faster inputs to arrive. But of course, you are losing on security or decentralization, right? So if your data availability solution is a quorum, then it can be very fast. But now if this quorum colludes and they want to break the application, they can. So all of these are trade-offs, but it's important to separate what is a limitation of the underlying data availability protocol and what's a limitation of Cartesi tech.
Great, Augusto. Thank you very much for your addings. So, guys, it's time for the last question, and it's a good one from Ariel. Is the project open to contributions from the community? And if so, how can individuals contribute? Yes, the project is open for contributions. All the development is doing in public repos. So just look at the repos, see things that seems interesting for you, and then started to code open PRs that will be evaluated and it will be discussed openly, okay? If so, the projects are open to contributions. If so, are there any active forums or channels where users and developers can discuss the project and seek assistance? Yes, our Discord server. There are a lot of channels dedicated for each product. Cartesi Rollups, Cartesi Compute, Cartesi Machine, Sunodo. So just enter in one of the forums related to the product that you are interested in, that you would like to contribute. Ask questions, send contributions, send doubts, send criticisms, and we will discuss and make the product better together, okay? This is the idea of this call, to share what we are doing with all of you, our development community, and also invite you to celebrate together the achievements of the project, okay? So it was a nice call. If, I don't know, any unit lead would like to say some final words, or can we finish? Okay, guys. So having a nice time. It was good to having all of you together with us, okay? Bye-bye.